Hello everyone. Today we are going to discuss the answers of the internal one for the numerical analysis of data examination of IIPS DABB. The first question was develop an algorithm or a flowchart or a program for solving the equation EX plus BY plus C and QX PX plus QY is equals to R. First, the logic part that leads to the algorithm is that we have been given with two equations. We find the value of x from equation 1 and we put that value in equation 2. Thus we get equation 4 as q minus pb by a into y is equals to r minus pc divided by a. We call this as equation 4. Thus we compute the value of q minus pb by a, that is the value of x, and replace the value of q by it and compute this and replace the value of r by it. We have qy is equals to r and y is equals to r by q. We now substitute the value of y in equation 3 and find the value of x. Thus this is the algorithm. Read 6 numbers and assign them respectively a, b, c, p, q, r. Compute q minus pb by a and replace the value of q by it. Compute r minus pc by a and replace the value of r by it. If q is equals to 0, then write no solution and stop. Else set y is equals to r by q. Set x is equals to c minus by divided by a. Write the value of x and y and the answers and stop. This is the algorithm for the first question. Now we see the second part of the first question. In this we have been given the value of a, b and c as 2.5, 5.2 and 6.2 and b, q, r is 1.251, q is equals to 2.6050 and r is equals to 3.1250. Given the answer correct up to 4 decimal places using floating point computation illustrates situation of ill-conditioned equation with change of coefficient q is equals to 2.6060. that is a very small change, and we have to see what is the error actually we have to see. So first we see the assigned values of these. We then normalize all the values such that the immediate number after the decimal is non-zero and before the decimal is 0, and e is the exponent. Then we write the algorithm, then we find the value of q, then we find the value of r, we replace it, we find the value of y, and then we find the value of x. We see that y is equals to 0.1666 e2 and x is equals to 0.217 e2, yet x and y values are already written, and then we stop as we have done in the previous part. We see that these values are different from what we got previously. Actually there's a 30% error value in x and y. Thus a small change in the value of q can lead to a large change in the value of x and y. And the reason for this is that we are using floating point numbers and we are actually using many operations, so there is a drastic change in that. Now we come to the second question. In this we have been given with an equation px is equals to a0xn plus an minus 1x to the power n minus 1 plus dash dash a0, and we know that this equation can be converted into this formula. This is the alternative representation of this. We have to write an algorithm for this for the evaluation of the above polynomial. So the given polynomial is this, as I have described in the question. We write it in a reverse order. First we take out x common, and then again we take out x, and again we take out x, and we get the final equation, this, which was the alternative representation. This is called nested parenthesis method. So for what we do, first we read x and n, then we apply a loop for I is equals to 0 to n in steps of 1, 2. We read ai, so we read all the coefficients. Then we take a variable p and subtract an from that. Then we apply the loop again, and we add the x, we add p into x in that p again, and then we write the final value of p. Then we'll stop it. Now the second part of the question was that obtain the recurrence relation of dividing a polynomial of px and write the algorithm for corresponding polynomial division by x minus r. So we apply the long division method here. Here's the polynomial a n x to the power n plus a n minus 1 x to the power n minus 1 plus dash dash a0, and we divided it by x minus r, and we obtain the quotient to be equals to a n x n minus 1 plus a n minus 1 plus r a n x to the power n minus 1 plus dash dash dash. We call the reduced polynomial this. We substitute the coefficient by bn minus 1, where bn minus 1 is equals to an, bn minus 2 is equals to an minus 1 plus r an, which can be written as a n plus 1 plus r bn minus 1, and similarly bn minus 3 can be written as a n minus 2 plus r bn minus 2. In general, bn minus I plus 1 is equals to a ni plus r bni. So we write the algorithm for it now. For I is equals to 0 to n, in steps of 1 to read ai, read all the coefficients. Then we need to find the b, the coefficient of the answer. bn minus 1 is equals to an, that's the first term. Then for the rest of the p terms, we apply a loop again. For I is equals to 1 to n minus 1, in steps of 1 to bn minus I plus 1 is equals to a ni plus r bni, and for I is equals to 0 to n minus 1, in steps of 1 to we then print all the values of b, and then we stop it. Now here's the third question. In this, we have been given a value of x is equals to 4.0110, and we need to find the value of this polynomial by two methods. First by straightforward method, and then by nested parenthesis method, which we discussed in the previous question. So in straightforward method, we directly put the value of x, which is equals to 4.0110 in the above equation, and then simplify and solve it and normalize it. While in nested parenthesis method, we solve the inner parenthesis first, then multiply it by x, and this way we get the final result to be this. Now the error value is equals to e calculated minus e actual divided by e actual. E calculated as 0.1846, while e actual was 0.781. So we find the error, which is equals to 0.9957, which is the huge error. Now the b part of it, we have to develop an algorithm for any of the bisection, secant and successive approximation method. I take bisection method first, and thus we know that the iterative formula is x2 is equals to x0 plus x1 divided by 2. So we read the 2 points between which the root may lie and the epsilon value. We put y0 to be fx0 and y1 to be fx1. Then we put I is equals to 0 in this. If the signs of both are same, that means root doesn't lie in this, we'll print it. If they are different, we'll apply the algorithm. In this, till the permissible value, that is x1 minus x0, is less than the error, is greater than the error, we'll shift x2 is equals to x0 plus x1 by 2, which is its iterative formula, and y2 will find it as f of x2, and we'll increase the counter by 1, and we'll check again if the signs are different or the same, and we'll write the final value of x2 and y2, and we'll stop the algorithm. I hope you have understood it. Thank you.